So this is the third part where we speak about functions as relations. Here we speak about some relations which are not functions, and we concentrate on infinite relations, and it will lead to a better understanding of the definition of functions. So recall that the definition of a function is a relation from a set A to a set B. We satisfy two conditions. The first condition here is the domain of f have to be all of A. The second condition says that if we have two pairs, here x, y, and x, z, with the same first coordinates, then the second coordinates have to be equal. That means a relation G from a set A to a set B is not a function if one of these conditions happens. The domain of this relation G is not all of A, and the second condition is that I can find the two pairs in the relation where they have the same first coordinates, but the second coordinates are not equal. So if one of these conditions happens, that means, or both, that means G is not a function. As example, we take this relation f, which is given by all pairs x and y, such that the first coordinates, which is x square, plus 4 the second coordinates, which is y square, is equal to 16. In this example, we want to show that f is not a function when we change the domain and the codomain. So, shows that f is not a function when we take f as a relation from the set of real numbers to the set of real numbers. And the second one, we show that f is not a function when we take it as a relation from the interval minus 4 to 4 to the real numbers. And we show that f is not a relation when we take f as a relation from the interval 0 to 4 to the interval 0, 1. This is the graph of f when we take it as a relation from R to R. It is the ellipse which intersects the x-axis in the point minus 4, 4, and the y-axis in the point minus 2 to 2. We see that from the graph, if the point x is inside the ellipse, then we can find 2 points here, say here y1, so that x and y1 is in the relation, and also here we will have x and minus y1 in the relation. But if x is outside the interval from minus 4 to 4, we cannot find any element with this x and y in the curve of my relation. This implies that the domain of this relation is not all the set R. For example, if we take x is equal to 10, then we cannot find y such that x squared plus 4y squared is equal to 16, because then substituting x is equal to 10, that means 4y squared is equal to 16 minus 100, and this is less than 0. It cannot be positive because here is supposed to be positive. So this one is not a function because the domain of f in this case is not equal to R. Now for the second one, we are taking f as a function from the interval minus 4 to 4 to R. So the graph of this function, we are looking on x only from this interval. And now for any x, we have something which is related to this x. If I take any x in this interval, I can find y such that x and y is on the graph of this relation. This means that the domain of f in this case is all the interval from -4 to 4. However, if xy is in the curve, then x and minus y is also in the curve. That means we can find two elements, two pairs with the same first coordinates x but different second coordinates, and this means this relation is not a function because it doesn't satisfy the second condition. So I can give a counter example. I can say the simplest counter example is 0 and 2, and 0 and -2 are in the relation f, but 2 doesn't equal to -2. That means it is not a function because it doesn't satisfy the second condition. The graph of the third relation from 0, 4 to the interval 0, 1 is just this portion of the ellipse. We have here 1 from 0 to 1, and here from the x from 0 to 4. Now this portion of the ellipse, it tells me that the points here doesn't have an image on the graph. Yeah, so it will not define for me a function. The domain of f in this case is not equal to all the interval from 0 to 4. As counter example, if we take x is equal to 0, this means 0 plus 4y squared is equal to 16, and this means y is equal to 2 plus or minus 2, but plus or minus 2 is not in the codomain, which is here is 0, interval from 0 to 1. So this one is not a function because it doesn't satisfy for me the first condition. Now we'll illustrate why this all of them are not functions by using graphs, but this is not considered as a proof. It's just for illustration. So let's see how we can write a mathematical proof. So for the first function f from the set of all real numbers to the real numbers, we can say that 10 is a real number, but 10 is not in the domain of the relation f, since 10 squared plus 4y squared will be always less than or equal to 100, so it cannot be equal to 16 for every real number y. So that means f is not a function. For the second one, the domain of f is the interval from -4 to 4, and we can prove it, but I will not prove it here. Now we take two pairs xy and xz in the relation f. They have the same first coordinates x, but the second coordinates can be different, and they put it here y and z. Now since they are in the relation f, we have 4y squared is supposed to be equal to 4z squared. But that means what? After cancellations means that y's can be plus or minus z. They may not be equal. So f is not a function. As a counter example, I can give you 2 and square root of 3 and 2 and minus square root of 3. Both of them are in the relation f. We have the same first coordinates, but the second coordinates are not equal. Note that to show that the second one is not a function, always it is enough just to give the counter example. So this last sentence will be enough to show that f is not a function. For the last one, when f is a relation from the interval of 0, 4 to 0, 1, we need to show that the domain of f is not equal to the interval from 0 to 4. And for this, I will choose 0. So we say that 0 belongs to the interval but 0 is not in the domain of f. Why? Because if 0 belongs to the domain of f, that means there exists y in 0, 1 such that this x and y satisfy the relation 0y belongs to f. But that means that what? It means that 0 plus 4y squared is equal to 16. Hence, y is equal to 2 or minus 2. But this is not in 0, 1 a contradiction. Now we finish the solution of this example. In next slides, we will speak about how to find the domain and range of real functions.